Measure the height of a building using a stopwatch. It might sound counterintuitive, but with a stone, stopwatch and physics, it is possible. So without any further ado, let's get into it. The first thing we need to understand is gravity. Every object in this universe is attracted to every other object by a force called as gravitational force. The magnitude of this force is given by universal gravitational law given by Sir Isaac Newton. According to this law, magnitude of force F is proportional to the product of masses of the two objects and is inversely proportional to the square of distance between the two objects. Combining these two together, we get force is proportional to m1 m2 divided by r square. Removing the sign of proportionality, we get a constant of proportionality g, and therefore our equation becomes F is equals to g m1 m2 over r square. This constant of proportionality g is called as the universal gravitational constant and is equals to 6.67 into 10 raised to power minus 11 Newton meter square kilogram square inverse. It is actually with this force that Earth pulls everything towards itself. In this case, one of the mass is going to be that of the Earth and the distance of separation is going to be the radius of Earth. In this situation, the force becomes Gm capital M over capital R square, where capital M represents the mass of Earth and capital R represents the radius of Earth. We also know that the weight of an object, which is also a force, is given by mass times the acceleration due to gravity. Now, as these equations represent force only, therefore they must be equal as well. Therefore, Gm capital M over R square should be equals to mg. Cancelling out small m on both sides, we are left with small g is equals to capital G into capital M divided by capital R square. Plugging the value of capital M as the mass of Earth, which is roughly 6 into 10 raised to power 24 kilograms, and capital R as the radius of Earth, which is roughly equals to 6.73 into 10 raised to power 6 meters, we will be left with the small g as 9.8 meters per second square. This small g represents acceleration due to gravity. What it means is that for an object dropped from a height has its velocity increased by 9.8 meters per second every second. Now, to measure the height of the building, we have to climb up to the top of this building. Once we are there, we need to drop the stone from the top. As soon as we drop the stone, we need to start the stopwatch, and once the stone touches the ground, we need to stop it. We will note this time taken by the stone to fall off the building. Now, we need to use the equation of motion S is equals to ut plus half at square. We have already derived these equations of motion. You can watch it by clicking on the I button or by the link in the description. The S in this equation of motion represents displacement, which in our case is the height of the building. U is the initial velocity of the stone and it would be 0. A represents acceleration and this is going to be the acceleration due to gravity small g. T is the time recorded by us on the stopwatch. Substituting these values in the equation, we get h is equals to 0 times t plus half gt square, which will leave us with h is equals to half gt square. We have already derived that g is 9.8 meters per second square, and let's say time taken by the stone to fall off the building is 2 seconds. Putting these values in the equation, we get h is equals to half times 9.8 into 2 square, solving which we get 19.6 meters. Thus, the building is roughly 19.6 meter tall. Why do I say roughly? Because we have not taken into account the effect of air resistance. Nevertheless, now you know how to measure length with a stopwatch. So this is all for this video. See you in the next one. Thank you for watching.